let's continue our exploration of testing. As part of this class, we're going to be working on a final project together. For example, a web browser for HTML and JavaScript. You'll want to ensure that it's correct, that it does what it's supposed to do. Now, one of the best ways to make that happen is to stop and think before you write anything and plan and reason about how the program will go. It's like designing a building before you set out to build it. If you have even the most rudimentary blueprints, your odds of success go up quite a bit. But often, we don't spend the time we would like, or we don't have the resources to plan everything in meticulous detail. So at some point, we just go out and write the source code, at which point you want to test the implementation. Let me give you another example of mistakes in testing by imagining that I'm going to make a mistake when writing our code to look up a variable in the environment. Remember that our environment is a tuple of a parent pointer and then a Python dictionary that maps variable names like x or y to values like 22 or 33. So when it comes time to look up a variable in the environment, we check and see if the variable name is in the dictionary. That's the 1th component of this tuple. And if it is, we just return it. So there are 3 cases. One possibility is we have a value for the variable. Another possibility is we are the global environment. Our parent pointer is none. So if we don't have it, no one does. We'll just return none. There is no value. Otherwise, we call ourselves recursively and look up the same variable in our parent environment. So these lines represent the correct code, but let's say I make a mistake and I do the following implementation. When it comes time to look up a variable in the environment, if it's in my environment, I give you the answer. Otherwise, I return none. I never ask the parent. We know this is a bug because I'm making a big deal about it, but it's easy to make mistakes when you're writing the code on your own. Let's remember this mistake, that I'm not going to look in my parent frame. All right, so let's go through this program and get a feeling for what it should be in our mind. A is 1, and we call mistletoe with 5, so Balder has the value 5. Now I assign it, we look up the old value, 5 plus 1 is 6, so now Balder is 6. A gets A plus 2, so 1 plus 2 is 3, so our variables are 6 and 3. Balder gets 6 plus 3, so Balder is 9. So the answer should be 9. However, with the bug, we're going to get an error because at some point we'll try to look up this variable A, and it won't be in our current environment frame. Current environment frame only has Balder. And instead of looking it up in our parent frame, we'll just return none, and then we'll try to add none to numbers, and we'll get the wrong result. We will be super sad. Balder was a god in Norse mythology, so beautiful, so perfect, that as a child, his mother asked all of the other things in the world to promise not to hurt him. That's quite the protection deal, but she forgot to ask mistletoe. So everything in the world bounced off Balder except for mistletoe. And in one of the stories in Norse mythology, it's variously told different ways. Loki, the trickster god, convinced another god to throw mistletoe at Balder. Actually, a common element in the story is that they were having fun by chucking things at him, throwing rocks, they'd just bounce off or whatnot. That's a little morbid, but I guess if you're invulnerable, could be fun. The person being asked to throw didn't understand the situation, threw the mistletoe at Balder, killing Balder. Very sad. In fact, Balder is sometimes compared and contrasted to Achilles in Greek mythology, who famously was invulnerable on all parts of his body except the heel. So anyway, this program should print 9, but instead it's going to raise an error. Let's say we don't know where the bug is. We don't know it's an environment lookup. What can we do to refine this test case so that it more closely points to exactly what's going on? Well, a common approach is actually just to comment out lines in your test case and see if it still breaks. For example, if I comment out these 3 lines in my test case so that mistletoe just returns Balder, we expect to write 5, and we will. So now we know the bug is triggered or the problem lies in one of these 3 lines. This is sometimes called fault localization because we're trying to zoom in on, localize, where the problem is.